Hi, this is the third module or the third video in the Lean Day module, one of three. And we will be covering quick changeover and error proofing. When was the last time you had a flat tire? Think about how long it would take you to change your tire if you did have one. Maybe 15 or 20 minutes by the time you found your jack, the tire iron, the spare tire, were able to get the car up into the air, remove all the lug nuts, put the wheel back on, lower the tire, and the whole process, again, may take between 15 and 20 minutes. Certainly, if you practice a few times, you could probably do it quicker, but to take everything out and do it properly, probably 15 to 20 minutes. If you're a NASCAR driver and you pull into the pit, if a pit stop took you 15 minutes to change a tire, you'd probably lose the race. Anyone that has seen a NASCAR pit crew where you have 4 or 5 folks jumping over the wall, maybe even 6, I'm not even sure, but they're changing 4 tires, they're refueling the car, they're making adjustments, they're possibly giving the driver something to drink, cleaning the windshield. There's a number of things that are actually happening during this pit stop. Consider it a quick changeover. They're changing over the vehicle, changing over the tires, and performing different functions to that vehicle, and their job is to do that as quickly as possible. Why do they do that as quick as possible? Because if the vehicle is not running around or racing around the track, it's losing, okay? And our machines, if our machines in our process are sitting idle and they're not going up and down or around, then we're losing the race. So what we've got to do is we've got to think about quick changeover much like a pit crew. We've got to think about how quickly we can get our equipment back online. And I'm even thinking about office environment. How quickly can we change from one job to the next job? Do we have to exit out and start screens from scratch, or can we, pick up from where we left off and not have to exit out and reestablish, our position with certain screens and procedures? If you think about healthcare and patients flowing through your facility, changing over from one patient performing an x-ray or some type of lab testing, what's the time element associated from going from one test to the next test? So this is quick changeover, and this is what we're going to discuss in the next several slides. So when we talk about changeover, we're going to talk about the time that the machine is idle or your process is idle from when you've completed your last part to when you're producing parts of the next part number, okay, or the next lot. So that's the time that we're talking about. That's our changeover time, and it's often referred to here as part-to-part changeover. Here's a few definitions. So let's look at the bottom of the screen here. We've got things that are internal to the process, and that's those are referring to the items that are done while the machine is stopped, while the operation is stopped. If we consider this a pit stop, this is where we're performing things while the car is in the actual pit lane or stopped at the pit. Those are the external operations. Those are the things that we're doing while the machine is running. So while the car is driving around the track, that's probably a good time to be thinking about getting the tire. If I'm the fellow that's going to jump over the wall with the tire, I certainly don't want to be looking for the tire while the car is sitting at the pit. I want to make sure I have that tire in my hand. Here comes the car, and we're jumping over the wall. Certainly want to have the least amount of things happening internal as possible. We have the opportunity to streamline the internal operations, and we have an opportunity to streamline the external operations. So now if we go up to the very top of this slide, we're going to talk about the process of how we're going to implement this. So the first thing we're going to do is we want to define what's actually happening. And we do this generally with a team of people. So I want to grab a few different individuals, maybe an operator, someone that actually does the changeover, maybe the engineer in the area, the supervisor, possibly even a maintenance person that has done some changeovers in the past. So we're going to grab a small group of people and we're going to observe what's happening during the changeover. So we'll watch an individual or a group of people, whoever is normally responsible with this, and we're going to watch them perform the changeover. We're going to define what happens during the internal and external elements of that changeover. All right, we're going to document this in writing. We're going to document it with pictures, and if it's a short changeover, sometimes we even like to take videos of this. After we get that information and we've collected it, we're going to take a look at what times are associated with each of those elements, and we're going to look at those internal elements, and we're going to consider which of those internal elements we can transfer to external. Those are some of the things that if we were looking for tools during the internal operation, then certainly we can move that to the external. So while the machine is running, let's go get those tools. If the machine is running, that's probably a good time to be getting material for the next job, blueprints for the next job, whatever we need to run that next job. Next, we want to streamline the internal elements of the process. Streamlining may be to not just have those tools available, but to have those tools readily available, properly identified, so that when we do grab those tools, that we're grabbing the right tools. Maybe we're going to color code them associated to the different parts that those tools may be used on. If we've got 5 or 6 different size nuts and bolts that we're going to be using tools on, well, is there an opportunity that we can make some of those similar? Maybe only have 2 different wrenches that we need. So those are some of the things associated with internals. Streamlining external, this isn't going to help us perform the changeover any quicker because it's happening outside of the change, but certainly if we have an opportunity to move things closer or streamline the external process by eliminating some steps, we certainly want to consider that as part of our overall lean methodology and lean enhancements that we're making to the process. So again, the steps through the implementation, this is a good reference screen for you. Go out and gather that data, document the process, categorize the items, whether they're internal or external. Develop that action plan. Again, the action plan is going to be, what are we going to do to convert the internal to external, streamline the internal, then streamline the external. Seek those approvals as required. Document the changeover procedures, the new things that you're going to perform, implement those changes, and then it's always nice to go back and review what's happening within your process and the changeover to make sure those things have actually happened and that you're maintaining those enhancements to your process. Some of the things that will benefit your process by more frequent changeovers or by a quicker changeover is that you'll actually have more frequent changeovers. You'll be more likely to run smaller batches, jump from one part number to the next part number because you won't really care too much about the changeover time because you've reduced it significantly. So it'll be a lot easier for you to run smaller batches through your operation. By simplifying your changeovers, you're most likely going to reduce scrap. You're not going to have a very complex changeover that may induce some errors to your process. So by keeping changeovers quick and simple, easy to follow, you're going to have new operators trained much quicker, and again, the opportunity for scrap or reduction in defects will be another benefit. Improved flexibility to the customer, obviously, with these other enhancements is certainly going to be a benefit. I'll give you an example. Years ago, I had an operation where we had film on a laminator used to coat 2 sides of a printed circuit board. We'd run a panel through there, through this machine, and based on the width of the panel, we had a different size film on that laminator. So we'd coat film to the top and the bottom of this panel. Say the panel was 24 inches, we had 24-inch wide film on it, and production control manager might walk in and say, I need you to run a different size panel. I need you to coat some 18-inch wide panels. Well, if I'm running 24-inch wide and I've got other 24-inch wide film in my room, or excuse me, panels in my room, then I want to use up as much of that film as possible. I don't want to change over and run 18 and then have to change back and do 24, because I'm going to lose probably a half hour to 45 minutes of setup time. So it's to my benefit to run that film until there's no more on the roll, and when I have to change over, I'll just simply change over and put the 18-inch wide on, and then I'll run all my 18-inch wide panels. Well, because I was horrible and our department was horrible at changing over, once that production control manager left the room, we basically kept running the 24, especially if there was only another, say, half hour's worth of film on that roll. We would just simply use up that roll and then switch over to the 18-inch. We'd switch over to the 18-inch film, maybe take us 45 minutes. Certainly the first job going through there would be that hot job that the production control manager told us to work on. That was one of our choices. The other choice that we had is we could put that 18-inch wide film through our laminator with the wider film on there. So we could run an 18-inch board through the laminator with 24-inch wide film, but then we'd have to trim the edges. By trimming the edges, we'd potentially induce some film chips into the process, which could create some quality issues. So we really didn't want to do that, but that was a shortcut that we could employ. Wasn't the best case scenario, but it was another way to again, run our process. And one of the reasons that we would do that is because we were horrible at changeover. So what we did was we finally smartened up. We got a group of people together, and we started to look at why does it take us so long to change over this laminator. And what we discovered, there were some pretty simple things and changes that we could make to our process that we could actually perform this operation in under 5 minutes. So we took this painful changeover process that was up to 45 minutes and sometimes even longer to do, and we actually reduced it to under 5 minutes. Now, the next time the production control manager walked in and said, can you change over from one size film to another, and we had about 4 or 5 different widths of film, we were very, happy to accommodate him, because again, it really wasn't going to hurt us in our throughput. So we worked on things not just based on our process and the limitations that our process had put on us. We worked on the process and the jobs based on the production control manager's schedule. Okay, so changeover. If you don't do a really good job with a changeover, it can really dictate your process. So we want to take those bottleneck areas, those areas that are painful, and make those areas so they're not painful anymore. So quick changeover, bring a group of people together and fix your process, and you're going to be very, very happy that you did. Error proofing is associated with defects that are created in our processes. So when we have a opportunity to look at our process, identify where the defects are coming from, whether it's the complexity of the process, failure of material, material that has large differences from lot to lot, or lot of human error or human intervention. Maybe we've got some machine problems. Anything that we can do to error-proof a process that can prevent defects, and again, defects can cause product to be scrapped or reworked, but certainly costly to us. So when we employ error-proofing, what we're doing is we're looking at reduction of defects and opportunities for us to have a much enhanced process by eliminating those. So errors can affect us, and error proofing can impact our safety programs as well as our processes. So if you look about safety and you're thinking about risk, check out this slide. And what these 8 individuals are doing here, I actually heard the story from somebody that was involved with the corrective action after this had happened. And basically, these 2 forklifts are involved with taking this unit down. This almost appears like it could be going up, but it's actually coming down. And from what was explained to me, the gentleman in the tan shirt on top of the orange forklift is actually acting as a counterweight. I'm not sure what the guy to his right is doing. Nobody's wearing hard helmets, or not that that would help them. It would probably prolong their time prior to death when this thing fell on and crushed their heads. But it's amazing what people do here. This is probably an example where you really couldn't error-proof this, short of having job safety requirements that people need to follow. But these folks got together and just didn't apply a single bit of common sense. So I guess the error proofing here that you would implement is proper safety training, proper usage of pieces of equipment, and any time that something like this would actually be considered, you'd have to have hopefully a manager step in, or a supervisor that had half a brain that could stop something like this. So error proofing is not going to cure stupidity, and that's really unfortunate. We're going to try to set up our error proofs so that they can't be bypassed, but there's an awful lot of error proofing items out there, or devices out there that can be bypassed. Where I worked in the past, if you bypassed a safety device or an error proofing device, they basically walked you to the door. And it didn't take very long for people to understand that if that was the consequence, then they weren't going to bypass a safety error proofing device or a safety device. So it's all about accountability. And in a situation like this, if these 8 individuals didn't lose their jobs, then certainly the person that was responsible for this operation should have. So here are 2 error-proofing things that we've probably seen in our day-to-day lives. The one on the left is this little tether. Prevents the gas cap from being lost. It probably costs anywhere from 2 to 3 cents to manufacture and put this on, and it's going to help us out. Another invention there is the fuel door has a little holder where you can place the cap onto the holder, and I guess that's maybe even a little nicer because maybe you don't have the fumes or maybe gas from the gas cap leaking on the side of your car. A couple years ago, I had an Outback Sport, little Subaru. Stopped at a gas station. I started to pump my gas. I had taken the gas cap off. I didn't have the tether or the spot on the fuel door, so I put the gas cap on the roof of my car. My wife had asked me to pull something out of the back hatch, and as I lifted up the hatch, I heard a little popping sound. So I'm pulling say the cooler or whatever from the back of the hatch, and meanwhile somebody that had watched what was going on called over to me and told me basically that my gas cap had flown over the top of my car. Basically what had happened is the hatch had pinched the gas cap between the hatch and the car rack, the rack on the top of the car, and it forced this the gas cap, the plastic cap, to launch about 25 feet over the top of my car. So of course I walk in front of the car after this guy's told me like twice where this thing is, and there's a little grass area, and sure enough, there on the ground is my gas cap. I walk back, finish pumping, and I put the gas cap back in place, and I'm thinking about this. Had this gentleman not told me about that, I probably, when I'm done pumping gas, wouldn't have remembered this popping sound, and I certainly wouldn't have associated it with my gas cap missing. And if my gas cap's not on the top of my car, I'm probably going to be looking around. Maybe I kicked it underneath the car. I'm going to be looking basically around my car, probably a few feet on all four sides of the car. I'm not going to be looking 25 feet in front of my car at a grassy area for my gas cap. Just not going to happen. So this 2 or 3 cent little tether would have prevented that from happening. And I'm glad the guy was there to help me out. So here's something where it would have, if I had this tether, I potentially not going to have to go out and buy another gas cap and have problems associated with things getting into my tank that I don't want, whether it was rain or anything else. The device on the right is a brake on a lawnmower, and most of the folks out there that have these type lawnmowers have probably bypassed the safety device by bypassing it with a piece of rope. I've seen bungee cords. I've seen little Velcro strips, because as you're cutting your grass and we've got to move the picnic table or the kids' toys out of the way or whatever, we don't want to have to shut off the lawnmower to restart it again. So here's the safety device, which is pretty neat, probably a little overkill, but something that has been put into place that we effectively will bypass. And again, bypass safety devices in some environments, you're going to get walked to the door. You do it at your house, well, that's your own choice. What's really sad is the story that I was told is that two gentlemen in upstate New York were neighbors, and the reason that that device exists on a lawnmower is that they decided that their hedges were too tall. Between the two of them, they didn't have a hedge clippers, so they decided to lift up a lawnmower and walk the length of the hedges, holding the lawnmower, one gentleman on either side. Well, apparently they didn't get to the end of the hedges when one of them slipped, and the lawnmower, whether it took off some digits and all, I don't have the rest of the story, but I can tell you that they sued, and one of the corrective actions was to put this device on the lawnmower, which is pretty scary to think that that was the reason that this was developed. We want to use a little bit more common sense when we're applying error-proofing devices, but these are relatively simple devices, mechanical devices, electromechanical. I believe the brake is a magnet. So there's a lot of different ways that we can achieve error-proofing. So we can actually inspect and prevent errors and defects at several different spots. And even if we can't detect an error or prevent an error from happening, and we actually have a defect that occurs, if we have an opportunity to employ an error-proofing device, or at least a device that's going to detect a defect afterwards, we'd certainly want to do that rather than pass defects along to the next operation or even on to the customer. So along with error prevention and defect detection, we're kind of grouping these all into the same boat. We certainly want to do things as early as possible into the process. So one of the things that we want to keep in mind is that within our processes, that there are going to be some defects that are going to be made, and if there's ways for us to prevent that from happening, then we certainly want to employ error-proofing devices as we can. So inspection, the note here, inspection improves quality. Inspection certainly does not improve quality, but what inspection will do for us is it will help us identify bad pieces and remove them from the process. What we do know is that inspection is not 100%, and that we are going to have escapes that go through our process. So it's really important that we look at ways to detect and prevent errors and defects from actually happening. I have a video attached to this this program, and what I'd like to be able to do here is ask you to stop and watch the video. What I'm going to ask you to do is you're going to watch the video, and I want you to count the number of times that the white team passes the ball to a different member of the white team. What you're going to be seeing is two groups of three people passing a basketball. They're kind of doing a weave in and out. The white team passes the ball to the white team. The black shirted team passes the ball to their team. So your job is to watch the video and determine how many passes the white team passes to the white team. I'd like you to do this twice and see if you get the same amount of passes from the first time you watch it to the second time you watch it. It's kind of important that you count each time. What I will tell you is that a pass is a pass from one individual to the next. It can be a bounce pass or a chest pass. What you're not going to count is if somebody drops the ball to the ground and then catches it themselves. We consider that a dribble. I think you'll see an instance or two of somebody dribbling the ball or at least bouncing it and catching it themselves. That's not a pass. So I want you to count again the amount of passes the white team passes from themselves, white shirted team to the white shirted team. Do that twice and stop this video now and then come back and we'll talk about that at the end of this presentation. All right, so you've watched the basketball video a couple times and we'll talk about that over the next couple slides. But in the meantime, I want to just explain some of the things that may produce some errors within your process. And when we have complex processes, or we've got complex tooling, or symmetrical tooling, where we've got the opportunity to put a product on a machine that could go on a number of different ways, and we haven't established an odd hole or unique sets of tooling. Those are all opportunities for errors. Even electronic forms on our computers that don't have the must fill-in boxes, those are going to provide us with opportunities for errors. If you think about the last time you were online and you were ordering something and you clicked next because you wanted to get to the next screen, but the computer wouldn't let you, the program wouldn't let you go to the next screen because you missed filling out a box or you didn't put the date in the proper format. Those are types of error-proofing devices that are not going to let you continue until you've completed all the information that's required and done it in the proper format. Very similar if you've put in a password for the first time and you haven't used the right amount. Maybe they require 8 different characters. One of those characters needs to be a number. One of those characters needs to be a special figure or symbol. So if you're not using their configuration, they're not going to let you continue. Those are all error-proofing devices. If you don't have those, you're going to have an opportunity to make an error. They want to collect your money at the end of the day, so if you haven't put in your credit card or added that 3-digit security code, they're not going to get their money, and they certainly don't want to let you continue without that. So what we're trying to do with error prevention and error defect detection is try to reduce this window of waste. So rather than the customer discovering the defects, what we want to do is we want to reduce this window area, and we want to detect them as close to that point of error as possible. So if in step number 2 we're creating a problem, we want to actually be able to prevent that from happening right there, or at least detect it as close to that error point as possible. So when we do that and say we catch it at the next step, then the window of opportunity here is shrunk significantly. And now if we go back in our process and we say, okay, what other product may be affected by step number 2 going out of control, we don't have to look around too far for our processes. We can say what happened between this afternoon and earlier this morning versus what happened over the last 2 or 3 weeks, because we had stuff escape to the customer, and that was the first time we were made aware of this issue. So by reducing our window of opportunity, we actually can control our processes and get to root cause and corrective action much, much faster. So whether we have error prevention or error detection, we want to reduce this window of opportunity as much as possible. If you have not watched the basketball video, please stop and, per the instructions back a few slides, watch that. And because I'm going to go over the results of that, and you really should be watching it before you listen to this. Okay, so I'm going to assume that you've watched it, and one of the things that when we talk about inspection, we talk about three things, sometimes a third thing, but I want to talk about repeatability and reproducibility. Um, One of the reasons that we need error proofing is because inspectors don't always repeat their inspections. So when I show this video to a group of 10 or 20 people, sometimes more, and I ask them how many passes they actually counted, um, I show it the first time and I get anywhere from 12, and I've gotten as high as 20 passes. Um, and then let the folks watch it a second time, and I get maybe between 13 and 16 passes. And what's really interesting is that people don't always count the same number of passes from the first time to the second time. And certainly, different people don't reproduce the same results. So the same person has an opportunity to repeat themselves. Different people reproduce their results. So there's variation from an operator to operator, and there's operator, we'll call it within variation. So did you count the same amount of passes from the first time to the second time? I will tell you that there are 14 passes. It looks like at one point there's a double pass. You can go back and watch the video, but there's actually 14 passes. And one of the things that I would ask you right now would be, what would be ways that we could error-proof this process so that we didn't count the wrong number of passes? Say this was a customer and we had to, give them the right answer every single time. What would be another way that we could accurately count those basketball passes? So an error-proofing way to look at this process. A couple suggestions that I've heard would be change the camera angle. If you think about 5S, what do you think 5S would have you do? Think about sort what you need from what you don't need. You would certainly remove people that had black shirts in the second basketball. We don't need them in this operation. We're only counting white basketball passes, so let's remove anything that's not, anyone that doesn't have a white shirt that's not involved with that. So that would certainly help us make less errors in our counting. May slow it down. You may ask people to count as they pass. There may be a counter on the ball that as it touched different people, it was able to automatically count. So there's a lot of different ways that we can change around our process. Maybe have the background be a different color. Maybe make the ball a slightly different color. The background is a little bit distracting. And for those of you that did not see a gorilla walk through the video, and I've shown this 3 and 4 times and actually had conversations about the gorilla, and still people miss the gorilla. What I'm going to ask you to do is go back and watch the video for yet another time to see if you see a gorilla walk through. Don't count the passes, just look for gorillas. So, when we talk about human error involved with a process and inspection, we don't always have full control over our processes. And people inspecting things are going to make mistakes. They're going to miss things. They're going to miss gorillas. And an example is, I go into an inspection area. I want an inspector to inspect some product for me. And I've got a particular customer that doesn't like a particular type of defect. So I'm going to hand this product to them. I'm going to ask them to inspect the product. and I'm going to say, geez, make sure we don't miss any of defect A. And it's really important that we don't have any escapes of defect A. I want you to inspect the entire product, but boy, this customer does not like defect A. Well, what are they looking for? They're looking for defect A. What are they going to miss? They're going to miss the gorilla. They're going to miss the big thing that is right there in front of them, because I've planted the seed in there, basically telling them to look for a particular defect, even though I've told them to inspect the entire board. So we need to set up our processes so that they're catching everything, including the gorillas. Okay, and so hopefully you were able to see the gorilla. Most people, I will tell you, do not see the gorilla. About 20% of the people that I show the video to that haven't seen it, and I always tell people to count the passes. I don't ask people to look for gorillas, obviously. So if you show this to anybody, make sure that you kind of set them up the same way that I set you folks up. And about 20% of the people will actually see the gorilla. This is a great selling point to improve our processes, and not just improve our inspections, which we obviously can do to reduce the amount of defects that get out to our customers, but really we want to use this video and error proofing to prevent defects within our process. That's the true use of this tool. That's the best use of the tool. Again, in a pinch, if we have to, let's detect those defects, but certainly let's try to prevent as much as we can.